Hey, what is good, everybody? Welcome back to another video. I'm gonna bless you guys with two videos today. How sweet is that? So in the previous video, we set up our metal layer. So in today's video, we are setting up our build system. So I did say we're gonna move away from from Xcode, and we're gonna move down to VS Code. Now, there's a couple of reasons why, and some of them are pretty much obvious, and that is because, well, sometimes Xcode isn't really the ideal IDE for these type of projects, and also we just want a little bit more control in terms of how we're compiling and all the other configurations that we can make as we go whilst building this game engine. So I have an empty project opened up. It's called G Engine. You guys can create whatever folder you guys want and name it whatever you guys want. There's currently nothing in this folder except for my settings JSON file in the .VSCode. This is just a configuration file for my own theme. So if you guys are interested in having the same theme as I do, this one is my own theme for VS Code. It currently just works for C and C++, I guess. I think I haven't really taken a look at the C++ side of things, but I made this specifically for C to basically highlight my syntax. To basically change my syntax highlighting colors for C, along with, I believe, my make files, because the build system you're going to be using is a make file system. It's not CMake. I'm sorry for those who thought it would be CMake, and for those who actually do like CMake. Unfortunately, I don't like CMake. It just adds a little bit extra layers to abstraction and all of that, and I'm not really a fan of that. So without wasting time, let's build our make file system, build system. So before I actually create the make file, let's talk about how we're going to structure our project here. So what is our engine? Do we want it to be a dynamic library, or do we just want it to be static, right? Infused with the application itself? Well, I don't know. What do you guys think? Well, I'm just gonna go with the dynamic library. So let's just create the engine as a dynamic library, and then we can basically use that within the application that we build in, right? So let's create two directories. Number one will be engine. All right, this one is where the engine code is gonna live, and then we're gonna have another one called app. Right, so the app is the application that's actually using the engine's DLL. All right, this can be our sandbox, this can be our testing ground, whatever you guys want to call it. And in fact, maybe I might just rename that to sandbox. Should I? Nah, it's fine. App is fine. I like apps, right? So in our engine, let's create a folder called source, and then inside there, let's just create a dummy file called defines .h or types.h or whatever, and then let's create another file in here called defines.c. You guys do not have to do this. It's just for me to test that our build system actually works. Okay, so do not copy this, but you can if you are actually following along step by step. But for now, you don't really need to copy any of this. Okay, so yeah, so let's do a pragma once in here, right? And then we just want to define like a basic function to test. So let's just do print hello or something like that, right? And then I'm going to take this and I'm going to go down into the implementation file, and I'm just going to say include defines.h, and then I'm going to paste this in here, and then I'm going to basically set this up, and I'm going to need a print. So we're going to need to get that from stdio io.h, like so, and then just save that. And you guys can see I have some formatting going on here. We'll discuss that a little bit later on. You're gonna use Clang format for this, but I do have a little bit of formatting going on. I think that has to do with my settings in there. I'm not quite sure, but anyway, in here we want to do a printf. Let's just say hello from engine DLL, right? Because we're going to compile this as a DLL, and I'm going to show you how. So let's do that. All right, so hello from engine DLL, dynamic library seems prettier. Don't quote me on that. And again, we have some formatting in here. This is not the type of formatting we're gonna have. It's just the default formatting that I need to essentially get rid of because I don't like it that it does that. But I'm not gonna deal with that for now. So yeah, let's save, and then let's go down to the app folder, and then let's create a source folder inside, and then let's create a main.c file. This is going to be our entry point, and we're going to include we're going to do std io.h, and then I'm going to do include int main. We're not going to have any arguments passed in, so that's fine. Leave that empty, and then return. This is starting to annoy me, but the whole formatting thing. So in here, let's just print out hello from app. Sweet. So let's set up our build system. So we're gonna create a make file. So this is where you guys can start to copy, because we're gonna build our make file. We're gonna code our make file from scratch, and I'm gonna try and explain as I go. Might not be perfect, because it has been a while since I did make files, and I believe I do have a video on my YouTube channel, pretty old, I guess. I think it's pretty old. It's maybe a year old or so, on how to basically work with make files. So yeah, it's been a while since I actually coded them from scratch, but we're gonna try in this video for educational purposes, just so that you guys can understand what's going on if you actually are following along with this series. So without any further ado, let's get started. So make files. I'm not really gonna start from the beginning. I'm gonna assume you know a thing or two about make files. So as I go, I will explain. So what do we need? We need build functions. I'm gonna call them build functions. I don't really know what you call them. So you basically start them off as this. You type phony, and then you give it a name. So in this scenario, what do we want to do? We want to basically scaffold our build directory. So I'm gonna call this scaffold. Okay, and then this function, we're gonna call it over here. So we're gonna say scaffold, and then we're gonna do this, and then we're gonna basically like tab, like yeah, just click tab, and it will just put you here. Okay, and then once you're here, all you gotta do is we're just gonna create a directory. So that's just gonna be make is it mk make directory? Yeah, mk. Yeah, I think it's mk. And then we're gonna do we're gonna make a directory. So we are gonna use $, and we're gonna give the directory a name. I'm gonna store that in a variable called build directory. So the directory that we're gonna be building to is gonna be called bin. You guys can call it build. You guys can call it whatever you want. I'm gonna stick with bin, and then that's the directory we're gonna make. So build directory like so. Okay, so now let's illustrate how this works. The power of make. So show up your new terminal, and here just type in make. Okay, I'm gonna click enter right now, and guess what happened? It created the bin folder for us using this function, right? Build command, or whatever you want to call this. I don't know. Okay, so it created this this directory called bin. So if I delete this, right, delete, and I run make again, watch what happens. So I'm gonna click enter, and then boom, we have a new directory called bin, right? And if I run this again, you'll see that it's already created, so it won't make it again, it won't duplicate itself. So that is okay. So then after basically having the build directory, we want to basically build our executable, which in this case is going to be our app. So how we're going to do that is we're going to need another function. So phony. Then we're going to call this I don't know. So I don't know. Let's app client. I don't know. I'll make this descriptive just so you guys can know what is happening. So we're gonna have like a function called build app, I guess, which will just build the executable. And then we're just gonna say build app. We're gonna call that, and then once this runs, it's gonna run the following code that we're gonna type in right here. So what we want to do is we wanna use Clang to compile. Okay. So we're gonna use Clang to compile our files, and right now we have a file called here called main.c, and it's located in app. So I'm going to type in app/src/main.c. Okay, then we're going to output that compiled code into an executable. And where is that going to be stored? It's going to be stored in the bin directory, and we're going to call the app, right? Yep, literally it's going to be called app. That's what's happening there, bin/app. That's our app name. Okay, and I'm going to save this. Then I'm going to come back down to the terminal, and I'm going to test this. So I'm going to say make. I'm going to run it with nothing except this. So I'm going to say enter. Then you're going to see what's going to happen. Nothing happens, but of course we already have the bin folder, so this won't get called again. But you'll notice that this is not being called. And why is that? This is just the nature of what a makefile, or how makefiles work. So when you just call make like this, right, it's going to run the first command that it sees, which is in this case the scaffold command. Now I'm calling it a command. I call it a function. I call it a build. Yeah, I don't know, but it's going to run the first command that it sees. In this case, it's scaffold. But I want to run this. So how do I run this? So all you do is just say build app, because that's what you called it, right? Make sure it matches what you called it here. So now when I click enter, you'll notice that it's going to say clang app/source main.c, and it's going to show where it's basically pushing that into. It's going to push it into the bin directory, and there it is. We have our app. So how do we run it? So let's do ./bin/app. I misspelled app. So let's do app. So when I run this now, it's going to say hello from app. And where's that coming from? It's coming from the main.c file, hello from app. And I'm just gonna put a new character here. That's why you're getting this what is this percentage symbol over there. So now what we want to do is come back into our build system, and we don't want to deal with this manually. I don't want to have to type app/main.c. Then when I add another file, for example, if I do I don't know, event.c, now I'm gonna have to go ahead, come back here and be like app/source/event event.c, and then I'm going to have to keep coming back to this build system to add these files manually. I don't want to do that, so I want to automate this. So how do we do that? So this is where our make build file starts to take some shape. So we need to basically partition this file into certain certain sections. So what I'm going to do is I'm going to define a bunch of variables, and then we're going to reorganize this file later on. Okay, so the app that we're building essentially is just an application. So the variables that I'm going to create here are going to be annotated with the word app. So I'm going to say app, and then I'm going to say app/compiler flags. So we're going to do a variable called compiler flags, like so. Okay, then I'm going to create a bunch of other variables, and the other one is going to be include flags for our include flags, and then the other one is going to be linker flags. So we're going to do linker flags like this, and finally we're going to have app source files, right? We're going to replace this with this. So, and I'll show you how. So app source files. Now we want to get the app the implementation files, the .c files, automatically. So this is what this variable is going to do, and it's going to store those files for us. Okay, so to do that, you want to do $, and you want to type in shell, and then you want to type in find, and then basically you want to pass in the folder that you want to look into, right? So the app folder is called app and source, and then inside we have our implementation files. So instead of me typing app like here, I'm going to store the name of this folder in a variable, just in case down the line we decide to rename it or change its letter to a lowercase letter or something. We can just change it in one place. So I'm going to say app assembly. Okay, and then this will be the root directory, right, which is app. So I'm going to say app. It matches up with the app that I basically typed here. Just keep that in mind. And then instead of just typing app here, all I'm going to do is make use of that variable, which is app assembly. And then all we got to do now is, let's see, we have, okay, so we're saying shell find, and then it's going to look into this directory. What do we want? We want the types of files, right? That essentially, let me just scaffold this out real quick. That essentially start with the name. We're going to do a wildcard there and end with the extension .c. So what does this do? So this essentially says, okay, look into this directory, in this case, the app directory, traverse through each and every directory that you find, each and every folder. It's going to go into the source folder and whatever other folders we have, and it's going to find any file that starts with, well, that basically has any name and then ends with a .c extension, okay? So that's what it's going to do. It's going to take those files and it's going to store it in this variable called app source files. Therefore, it's going to find .main.c, it's going to find event.c for us, so we don't have to do that manually anymore. All we can do is say, all we can do now is just say $, and then app source files like this. So let's test it and see if it works. So I'm going to clear up my terminal, then I'm going to run make again, and you're going to see again this is going to get very annoying because every time you run make, it's going to only call the first function, but we want this one being called as well. So how do we make it automatic? Because I'm pretty sure you guys don't want to do this. You don't want to be typing build app every single time. It gets exhausting. So let's automate this. So up here, we're going to do all. I'm going to write all, and we're going to say scaffold. Then we're going to say build app. So what this does is whenever you now type make is going to run whatever first command it sees, right? So this is a command. And this command is essentially just calling these two functions, right? Scaffold and build app. So it's going to start here. It's going to call this. Once that has been called, it's going to see, oh, it still needs to call build app. Then it's going to call build app so that we don't have to tell it explicitly to do that every single time. So I'm going to save this make file, and then I'm going to run enter, and then boom. See now it's saying clang app main.c event.c. And notice that I didn't type those manually here. It just did that automatically for me. And that's the beauty of that function. Sweet. Great. So now let's test and see if our app still works. So bin/app like this, and then it's going to say hello from app. Beautiful. Sweet. So what I'm now going to do is up here, I'm going to partition this make file. I'm going to separate some logic. So I'm going to say, what do I want to call this? I don't know. Let's just say application stuff will go underneath here. All right, so application stuff will go underneath here. And then we're going to have engine stuff. But for now, we know that the application is essentially running. What we want to do now is test if these guys will work. So I'm going to go down to my main.c, and I'm going to type in something that is not supported in C99, which is a Boolean. You have to manually define these or just include std bool, but I know that it's not defined in C99, so I'm going to say bool, and I'm going to give this a name of, I don't know, my Boolean. Right? And I'm going to do this, right? And yeah, I'm going to save it. And you're going to see Xcode is also going to pick this up, and VSCode is going to pick this up and say undeclared identifier, boom. Okay, so I'm going to save that. It's fine. Then I'm going to come down to my terminal. I'm going to clear this. I'm going to run my make, and then you're going to see something. It's going to say use of undeclared identifier, boom. So I know that C99 doesn't support this off the back. So all I can do now is come here on my app compiler flags and do std. The standard, and we're going to use the C2X standard. This simply just means C23. Okay, so I'm going to put X in place of 3, and then I'm going to save this. Then in here next to clang, we're going to use that variable, and I'm just going to type app compiler flags. Sweet. So now I'm going to save, then I'm going to clear my terminal. Again, oops. Then I'm gonna make, and then you'll notice that it's now using the C2X C23, and we don't have any compiler errors anymore. That undeclared identifier is gone now, but in Xcode it's still very much there. For whatever reason, VSCode doesn't support C23 syntax highlighting for whatever reason. I don't know, but I'll show you how to get rid of this in our C.cpp properties file, which we're not going to do in this video, unfortunately. unfortunately. But I don't know, we might. We'll see how far we get. Okay. But anyway, so now that we know that the compiler flags thingy is working, we can go down and do our include flags. So our include flags, essentially, let's say for example we wanted to use something in the engine folder here, so we wanted to use that function that we created, the print hello function. So how would we go about that? So let's do this. Let's do yeah, let's come here, and we're gonna start with a capital I, meaning include. Then we're gonna give it a folder. In this case it's called engine, right? And then it's gonna be inside source. Okay, so this is just gonna point to say, hey, whatever header files we're looking for, we can find them in engine.source, and then we find that defines header file that we're gonna be looking for. Then I'm gonna take this include flags and maybe just put them here for now. Okay, then I'm gonna say app include flags, save. Then in our main.c, we're gonna come up here and do include. Then we're gonna say defines.h. Okay, I'm gonna save that. And then in our terminal, we're gonna clear. Then we're gonna make. Then let's see if we have any errors. We don't. So we do know that we have a function in there which says print hello. So let's do print hello. Let's call it, and let's test if that linking is actually working. Okay. So make again, and it's gonna say undefined symbols for architecture ARM64. In this case, being print hello. So it's not finding it, and it's a pretty good reason why, right? It's not finding it because it's defined in the C file. So what I'm gonna do is I'm gonna copy this, and just for testing purposes, just come back here, just paste it in here, and just comment that out, and just do an include here. Let's do stdio like so. We cheating, I know. And then we're gonna clear our terminal. Then we're gonna make again, and it should run now. And then when I do /bin run our app, it should say hello from engine dynamic library, but of course the engine hasn't really been built yet. We're just using this header file directly, but then we can see that it is actually working, right? So now we can basically link these header files. All we can then do is come here, and I think that's it for now, right? And then the only thing that I'm going to do is just over here, before I even forget about it, is I'm going to make use of this app linker flags. So app linker flags, and it currently has nothing set. So far we're making use of the compiler flags, the include flags, and then lastly the app linker flags, which we will fill out as soon as we have our engine code build phase also stood up here. So yeah, so let's do the engine now, right? So let's start compiling the engine as a DLL. So to do that, I am just going to do this real quick. Just add that like so. Then I'm going to copy this, paste it here, and then instead of application, we're just going to say engine library. Okay, and for that, we're just going to copy everything that we have here into here, and then instead of app now, it's just going to be engine, and then just make sure you make the necessary changes where they need to be made. Engine, and finally over here and here as well. And that's about it. And then we're going to change the assembly to engine. This name matches the folder. Engine starts with a capital E, so do make sure of that. And then the logic is the same. We're going to find the source files in here, and then we're going to look for everything that has the C file, the C extension. Okay, so now let's see. What do we need to change? Nothing so far here. So the only thing we need to add is make sure that the engine, when it gets compiled as a DLL. Okay, so I'm going to show you, actually no, it's fine. Let's do shared as linker stuff. So we're going to say shared because we're going to build a shared library. Then it's going to be dynamic. So we're going to basically tell the compiler it's dynamic by using that line. And then because I'm on Mac, I need to use something called install name tool, but I think this one is also fine. And then all I need to do is just give it the R path of the library, and that will be lib. And then the name of our library is tisk. I guess we can make use of the assembly variable, which is engine, so it's going to be lib engine.dolib. So I'm going to make use of that variable, so I'm going to say lib engine assembly, which is just engine, and then we're going to give it an extension. In this case, just going to be a dylib. And I believe on Linux systems it's going to be so.so, and then on Windows I think it's a dll, right? The extension is just a .dll. Correct me if I'm wrong, but I think that's how it is on the other platforms. So Windows is a DLL, Linux is a SO, and then macOS is a dylib. Okay, keep that in mind. So now that we have our engine compiling as a dynamic library, we basically also need no, actually it's fine. Yeah, it's fine. And the only thing we need to change is this, because now we're not building the app, we're building the engine. So build library or build engine, like so, and then just copy this, paste it up here. So now when we call make, it's gonna call scaffold, then it's gonna build the app, right? But actually we want to reverse the order now, because we have engine. We want to build the engine first, which is a DLL, because the app relies on the engine's DLL. So yeah, so this is the order that we're going to be calling this in, and that's the order we've basically coded this as well in. So given this, I guess we can test it and see if we made any errors and mistakes. So what I'm going to do is I'm going to delete the bin folder, just for good measures. Then I'm going to type in make and then see what happens. So now what do we do? So redefinition of print hello. Oh yeah, so I can now finally get rid of this, and I can finally put this back, and then this should stay the same, and everything should be the same here. So save all those files, come back in here, and clear up, and then run make again, and then it's going to say undefined symbols for architecture ARM64 print hello. So we're missing something. Let me see, what could we be missing? Oh yeah, right, so we're making use of the engine now, right? So now this defines doesn't work, because we now using the dynamic library definitions, right? So we replace that with these arrows. So save that, come back here, and to also account for that in the application build step, in the linker flags, what you want to do here is basically tell it where the library is. That's why it can't find these symbols. So the library, you annotate with a capital L, is stored in the engine directory, right? So I don't want to type engine manually here, so all I'm going to do is going to use the variable called engine assembly. That should give us the folder that we're looking for, and then it's going to be in the source folder as well. So save this. And then also here, I don't want to type engine manually, so replace that with the variable instead. So engine assembly, like this. So this is for the header files, and then this is for the library linking such stuff. And then all we're going to do is say a small letter L, and then we're going to do a variable. And then this variable will be the engine assembly, because it's going to get the engine's DLL library. It's going to link with that library, because it's called engine. And then what else? So we basically showed where the header files are for the engine, then the library location, and then finally linking with that library. And because we're linking with this library and I'm making use of this, it's probably good that I also include the following line. So I'm just gonna say W WL, WL, this, and then we're just gonna do a slash r path like this, then a comma, then a dot. Okay, type it like this. Otherwise you're gonna have issues, right? Don't leave any spaces in between. Type it exactly how I typed it. And then I believe this is about it, right? Yeah, so let's see. Clear up the terminal. Let's see if we have anything in our bin. No, we don't. So let's run make again. And then it's going to say engine not found. So something is not working. Right. It's not found because here, see, notice this? We're building app. And this is a dynamic library, so this won't work. So what we're going to do is we're going to use, instead of typing bin manually, we're going to make use of the bin directory variable here, which just equals bin. So we're going to do $, then type in build directory, then slash, then the name of our library. And good thing is we already have that over here. So copy this, paste it in here. So our library will be called lib engine.dylib. Save that bad boy, and then I think that will clear our linking errors. So make and library engine not found. Library, here it is, engine dylib. It's not found. What do you mean it's not found? What do you mean? What do you mean? Okay, let me read what I typed, because I probably might have typed something incorrectly here. So we're basically showing, okay, let me also change this into a variable. So engine assembly, engine assembly, engine assembly, engine source files, engine compiler flags, engine linker flags, engine assembly, engine linker flags. Okay. Scaffold, build engine, build app. So in here, engine is not found. Very interesting. Oh, yeah, I know why. Because yes, I'm giving it the location of where the engine is, but the location is actually wrong. I'm saying it's in the engine folder, but that's where our files are, source files are. So instead of engine assembly here, it should just be build directory, because that is where the engine is going to be stored in, and that's where it is located. So just save that again and clear here and run make. Engine still not found. Bin source. Oh, we don't need that anymore. So yeah, it should work now. Yay, it works. So if I try and run this now, so bin slash app, it's gonna say library not loaded. Good work. But that's because I'm calling it this way. So what you want to do is explicitly cd into that bin directory. So I'm going to say cd bin. Now that we're in the bin directory, all you want to do is just say /app. And boom, hello from app, hello from engine dynamic library. So the linking is working, and we are finally making use of our engine DLL stuff. So that is pretty sweet, isn't it? So all we want to do now is port. So let's port the engine source files into our VS Code folder here. So what I'm gonna do is I just going to get rid of this, move this to trash. Then in the engine source here, I'm gonna delete everything that you see. Okay, move to trash. Now we have nothing. Now we're gonna go down to our Xcode engine project and basically move all of this into VS Code. That's gonna be fun. Yeah, that's gonna be fun. All right, so how are we gonna do that? Um, is there a way to locate these files? So show in Finder. Yes, there is. So that's good. That will save us quite a lot of work. So just copy these, copy, and engine source. It won't allow me to paste, so just say reveal in Finder, and then inside source we just going to paste those 4 items from there. So source, actually what you want to do is create a new folder. Let's just do this. Source platform, actually. Then we're gonna move all of this into there, into platform. And in the source folder we're gonna need another folder called core, and there we are simply going to copy paste these guys. Copy, then here we go to core and just paste those 6 items, and we should see that propagating in VS Code like so. And this is good. This is good. We're having good progress. So now what we want to do is that we have all our files, and then the main.c file looks like this. And how are we making use of this? Currently what we're doing is, let me see, we are explicitly calling these like this. So I'm thinking that we should probably just keep it this way as well for now. In future we're gonna replace this with just one include header, include thingy, and it's gonna be something like I don't know, engine.h, right? And then we don't have to include all these things. We just include this and it'll give us everything that's in the engine itself, right? But for now we will keep the same structure, so it's fine. So now that we have the engine stuff, let's see if the engine will get compiled. Right? Yeah, let's see if the engine will get compiled. I do know these will give us issues, so let's not include this, and let's also remove this at the top. So let's try and clear. Let's cd back into the root directory, and then let's run our makefile. And use of undeclared identifier, which is print. So let's do this. Let's say printf. Let's just do a hello world for now, I guess, right? Like so. New line, and then save this. And then what I'm gonna do is just clear the console terminal, whatever, and then rerun that again, and you'll notice that the engine does get built successfully. Interesting. So it's good that that literally just worked off the bat. Nice. But I do know there's gonna be issues, and I'll show you what I mean by that. So we have the engine. Now how are we gonna use it here? So all we're gonna do is we're just gonna say include, and we're gonna say core slash what are we including here? Event.h. So event dot h, like this. And what's the other one? Input.h, like so. And then the other one is the platform. So I just gonna paste this and remove those quotation marks and replace it with this, and then test if it will pull those in. So here, make, and no issues so far, at least. So let's try and create a window. Let's try and show a window. So I'm gonna copy all of this, and probably just put it off the hello world. Now we have 2 hello worlds, which is weird. So get rid of the other one, save this, clear the console, and run make again. And then it's gonna say that these are not defined, so let's copy these and paste them up here like so. And let's clear up our terminal, let's run make again, and voila, Sweet, 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 sweet. Now, this is what I wanted to see. These are the issues that I've been talking about. So notice what we have here. It says platform initialize, platform poll events, platform show close, platform shutdown, platform create. Where are those defined? Those are defined in our platform folder inside platform.h. And when we go down here, you'll see here they are. However, the implementation falls under a Objective-C file, and VS Code is bad at highlighting Objective-C code. You can see the syntax highlighting in here is just, yeah, it's pretty much non-existent, really. And you also don't have IntelliSense as we do in Xcode, hence why I started doing this in Xcode, because of the IntelliSense, because Xcode was meant to handle Objective-C, Swift, and all the other Apple related languages, right? So how do we compile this file? Because if you look at our make file, we currently just looking for .c files and this is a .m file. So how do we handle that? Well, ladies and gentlemen, that is where things change a little bit. And it doesn't really change too much. All we have to do is just add support for that extra file. So to do that, essentially, all I'm going to do is, I think it's right here, is I'm going to just say also take in the name or the files that start with the following name, just a wildcard, and ends with the extension .m. I think this is it. So let's try and compile this, and if it does compile, it's going to give us extra new warnings. So let's see. And yes, it does. So it did compile, and now we have incompatible integer pointer conversion cast to let's see, 2 errors generated. So this time file stm time, what did I cast this to? I do know that I casted it somewhere down below to a const char, I believe. Let's see. What was the other one? Yeah. I don't know. Let's see. If this is the issue. Sorry about that. And I guess that fixed it for now. Unfortunately, now we have a lot of Objective-C errors. So our build system doesn't take into account that we're building on a Mac, and we also basically need some Mac specific stuff, and that's basically related to Objective-C. So in our link of flags, all we need to do is just do link with the Objective-C library. So LOBJC, small case. Okay, then in our compiler flags up here, just do dash big O OBJC and then big C, right? Like so, OBJC. And save this. Now we're taking into account Objective-C. So now when we clear and we make, we should get new errors, and we still do. Now the errors are different. Now it's saying NSApp, NSLog, and Objective-C class, NS applications are not found. These belong to a framework, and that particular framework is basically Mac related. So in our link of flags, right after this, all we can do is say framework, and then just say appkit, and then framework, I guess foundation as well. So let's save these two, and let's see if it reduces the amount of errors that we have. And it does. And now all we need now is CA Metal Layer, which is another framework. It's located in, hopefully I can remember how to spell it, Quats core, something like that, right? So save that, clear your terminal, make this, and it should get rid of that error. And our application gets compiled successfully. So let's cd into the bin folder, and then let's try and run it. Let's see if it'll work. Now I'm expecting, oh, application launched successfully. Ooh, there it is. So we do have our window again, ladies and gentlemen, and it's working in VS Code successfully. Now there is one thing that is annoying me, and let me show you. So I'm running this, and it says application launched, but it's not taking me to my window, right? I have to do this, and when I do this, it disappears, and I have to click it. So that's one thing I believe we forgot to add in our platform layer. So let's go down to platform macOS, and let's go down to where we are creating our dynamic library load. Nope, we're looking for platform setup. So that is, let me just search. So platform init. So in our initialization routine, I think down here is where I have to say, well, I don't have IntelliSense there, so I could basically type something that's incorrect. So let me come back to VS Code and go down to where we're initializing, and let's just say ns app. I think it's ignore. No, it's not. What is this? Actually, let me see if I have this supported in the other engine. Let's look at the engine source platform macOS. Let's go down to the macOS one, and I'm looking for the startup routine here, and ns finish launching. Interesting. Set. Yeah, this is what I'm looking for. Ignoring other apps, right? So if I do search for that, let's see. Let me just get rid of a few things. And then put this here. Let's see if I actually am calling this somewhere in the code, and I'm not. So I'm gonna put this here. And I'm gonna save. Then clear up my bin. Then go back to our root folder. Then basically run make again. Then cd back into the bin folder. Then call the app, and boom. Ladies and gentlemen, it takes us to the window when it opens up on launch. So that is good. So this is what I needed to add. This is what we were missing. And it's good that I caught it right now. Otherwise, it would have been frustrating. But anyway, it works. But now do you guys see why I actually started in in Xcode? Is because we don't have IntelliSense support for Objective-C, and we only have it in Xcode. So yeah. So I guess this is where I'll leave it for this video. Yeah, I guess this is where I'll leave it. Actually, no. Before I actually do end this video, let's do our CPP properties thingy. So what I'm gonna do is I'm just gonna copy it from my other engine. Just gonna copy this. So let's do a copy, and then in here we are going to do a paste, and we're just going to change the stuff that we don't need. So here it was called the sandbox, so here it's called app. Then Vulkan. Ooh, Vulkan is already here. But yeah, we're gonna get to this when we get to Vulkan related stuff. We pretty close. But what I want you guys to copy from this file is essentially this part. Well, just copy the whole thing. Yeah, just copy the whole thing. And then the C standard here is C23. The CPP standard is just C++23. Not that we're going to use C++ or anything. Then the clan compiler, IntelliSense mode is the Clang ARM64, and then the compiler path. I essentially downloaded Clang, the latest version of Clang. You guys can do that as well. I used Homebrew to do that, and then this is the path that it is given by Homebrew. So I'm making use of this Clang to essentially compile my projects. So yeah, I'm not using the default one that comes with Mac. I'm using the one that I just downloaded off camera or whatever. But anyway, yeah, so that's our CPP. And then the other thing I think I should also maybe do in this video is just copy the Clang format stuff. Ooh, I don't like this. I think I have a better version of this that is in my plugin system. Where are you? Here it is. Yeah. Still the same. Really? Interesting. So I don't know if I want to copy this right now, because there are certain things I don't like in these default ones. And also we have some comments in here, so I think I'll do a separate video for this one, for the Clang format. Yeah, it's fine. I will do a separate video for that, simply because yeah, I don't have an already cleaned up one. Wait, let's see. Basic engine, I think it's in here. Yes. See, the good thing about coding multiple engines, you just have it here and there. So I'm gonna take this, okay, and then I'll leave it on the screen so that you guys can copy it. So back into our engine project, in our root right here, I'm just gonna say paste, and that's gonna paste a .clang format file, and this is the settings that I'm using. So you guys can pause the video, take your screenshots, and use them in your project as well. This is what we're going to use to format our C code, and hopefully now you guys can see that in the works. So let's basically try and format this file. So I'm going to save, and boom, so it gets formatted. You can see these are aligned, these get aligned. You guys can tweak it to however you want, but then our code base is now basically being properly formatted. So if I save in here, everything gets properly formatted. If I save in here, everything gets properly formatted. If I save in here, everything gets properly formatted. If I save in here as well, same story. And you'll notice that these guys also get reorganized. So in here, if I save, you can see they got reorganized. Platform.h, if I save, things just get aligned nicely. And then in here as well, well, there isn't really much to format in here. Will it work for this file? Nope. And then the platforms.h, boom. So now we have proper code formatting. And how does this work, you may ask? So how is this picking up that I have a Clang format file? That's in our settings.json. And I believe it's somewhere up here where it says editor.format on save. Make sure you have this property set. And then what else do you need? I think that's actually the only thing you need. Yeah, that's the only thing you need. Yeah. And then, yeah, if you guys want the theme, this is my own custom theme that I use for VS Code. So you guys can copy these settings if you want. That essentially gives you this color scheme, for your C code. Yeah, this is my style. This is what I like, and it also basically covers the makefile, hence why it looks this way. So you guys can copy that settings as well. So yeah, if you guys enjoyed this video and would like to see more, definitely hit that like and subscribe button. It definitely helps me grow the channel, and it keeps me going. So I'll see you guys in the next video. Take care.